taking a look at these two, we've got Z1 times Z2, so that's 1 minus 3j times minus 2 plus 5j. Multiplying 8 gets minus 2 plus 5j plus another 5j. That's 15. Think together. That becomes, you're happy, that becomes plus 15. Plus 6, I beg your pardon. So you becomes plus 15 straight off, yeah? So minus 2, 15 is 13. Plus 5, plus 6, plus 11j. And then taking that result, so 13 plus 11j, and multiply minus 3 minus 4j. 15 times minus 3 is 39, minus 39. 13 times minus 4, minus 52j. 11 times minus 3 is minus 33j. 11 times minus 4 is minus 44 j squared. Comes minus 39 minus 44 minus 83, isn't it? Where did I get 5 from? Have I done that wrong, boys? Come on, help me. Yeah, bringing these two together becomes minus 85j. Oh, 4, doesn't it? Yeah. 5 minus 85j. Thank you for looking. Alright? So that's multiple of rectangular or Cartesian numbers, J numbers if you like. Alright? Now, the mathematical operation we need to look at but the preamble requires talk about what's called the complex conjugate of a Cartesian number. What a mouthful that is. I'm not. I wish I was, but I'm not. The makes it sound complicated, but it actually isn't very difficult at all. The complex number is found by simply changing the imaginary j part. If you've got a plus j part in the conjugate, you leave all the numbers the same, but you make it a positive j part. So the complex conjugate of 3 plus 2j is 3 minus 2. Its conjugate of minus 5 plus 4j is minus 5. Is use your skills you've just been using to multiply all those 4 together. See if you see Right guys, the way I'm going to write this out so that you can see where the general solution comes from, or what the actual constant is made up of, is I'm going to write it like this. Guys, this one, 3 times 3, 3 squared. Yeah. 3 times minus 2j, minus 6j. 3 times plus 2j, plus 6j. And 2 times minus 2j, 2j times minus 2j is minus 4j squared. Let's put, leave it like that. Okay, so we got equals 3 squared. Those two cancel out. That's minus 1, so that makes that plus 2. I'm going to make it 2 squared. That's those two numbers squared, ignoring the signs. Yep. Okay. Which, as you have rightly said, equals 13. Right? Here again, minus 5 times minus 5, 25. I'm going to write it as 5 squared. No, but what I'm trying to show you is where that constant comes from. So it's always going to come from the square of the two numbers, yeah, added together. Right, 5 squared. Quickly say the 2j terms cancel each other out. Okay, and we end up with, on the end, plus 4 times minus 4 is minus 16j squared. That becomes plus 16, so is equal to 5 squared plus 4 squared. (41). Yep. This one is going to equal 2 squared plus 8 squared. Because it's just these two numbers, ignoring signs, squared. Always. So that's 4 plus 64, 68, the third one. 6 squared plus 3 squared, 45. So the general result down the bottom is a plus bj times a minus bj is equal to a squared plus b squared. So when you multiply by a complex conjugate, so you multiply one complex number by its own complex conjugate, you end up with a constant that is those two numbers there, a and b, squared and added together. Alright? So, by all means write things out longhand to get a grasp of it, but that's if you can remember that, you can speed things up a bit. Alright? So, the reason for doing it. Division of complex numbers. So we're going to divide 2 minus 5j by 3 plus 5j. The way we achieve that is that we have to multiply the numerator and the denominator by the complex conjugate of the denominator. Because what that'll do is make the denominator a constant. We've just seen that. Okay, so we'll go through this one step by step. So what we've got to do is say it equals 2 minus 5j over 3 plus 4j. And then we have to multiply top and bottom. So what we do at the bottom, we've got to do it to the top. So we multiply the bottom by 3 minus 4j We've got to multiply the top by 3 minus 4j2. Alright, we already know from what we've just been doing that this bottom piece turns out to be 3 squared plus 4 squared. Happy with that? Yeah, and if you don't remember it, you're just going to have to do the multiplication out, and that's what you'll end up with, a constant. Okay, and then the top we've got to multiply out as normal. So 2 times 3 is 6. 2 times minus 4j is minus 8j. Minus 5 times 3 is minus 15j. And minus 5 times minus 4 is plus 20j squared. They're on the ball. Okay, bringing like terms together, we know that constant on the end becomes what? Because of the j squared? Negative 20. So a 6 minus 20 minus 14, yeah, and minus 8 minus 15 is minus 23j on the top, all divided by 3 squared is 9, 4 squared is 16, so that's 25. Yeah. So what it is equal to is minus 14 over 25 minus 23j over 25, and you can turn them into decimal numbers if you so wish to do so. I will often depend on what you want from it, Kieran. Yeah, I mean, I like the idea. If you can simplify the fractions, like if that was 4 over 2, you can make it 2. But if they don't easily simplify, rather than round a decimal number to 3 decimal places or something and bring in an inaccuracy, you're far better off staying with the fraction. Okay. Certainly, if you're going to convert that to a polar form, you probably want to put it in your calculator like that particular one. Because if you, I don't know what 14 over 25 is, but I would think that's a long decimal number. I was only 2. So in that case, then you count full accuracy. If you do any rounding, you're introducing inaccuracy. So if you can stick with fractions, I mean, what's 23 over 25? Neither of them are too bad. What did you say it was, Daniel? With 0.56 minus, what was it, Dan? You could write it like that as well. But remember always, if it fills up your calculator with decimal places, then you're probably better off leaving it as a fraction. The classic ones are 1/3, 1/6, 2/3, them ones. Because so often I see people round 2/3, 0.6666 to 0.6 is amazing. And it doesn't round to that. If you round it to 1 decimal place, it rounds to 0.7, not 0.6. Yeah? It's far too much rounding, that is, to round that to even to 0.7. Far better to deal with the 2/3 or the 1/3. Alright? Yeah. So that's how we divide Cartesian complex numbers. On the next page, there are a couple for you to have a go at. So yeah, you writ out like this. Yeah, so you multiply them by and the bottom line is That's what you got to do.
I'll turn the other way around.
Yeah, well,
That makes
you still end up with the same result.
then in that case, the bottom line is 3 squared minus 4 squared.
Bottom line,
This is where I think I'm going wrong. Plus 3 squared, so that's minus 3. And then I've got,
yeah, but minus 3 squared is always also plus 9, so don't make no difference,
yeah,
does
yeah,
it?
I've got that.
Yeah.
And then I've got minus 4 squared, which is positive 4 minus negative.
No, but it's just the number squared, remember, we already determined that.
So it's just positive.
Never, remember, when we done all them constants, none of them ended up as negative, did they?
Yeah.
So is that where you're gone wrong then?
Okay.
Yeah. On the top here, we end up with minus 3. Well, if we go back to, but if you're not getting why that happens, then perhaps you need to do the whole multiplication of that minus 3 minus 4j multiplied by and then we minus 3 4j. To bottom line, They're, I don't even know who. Got as minus 3j minus 2 plus 5j plus 5. Okay. Lines 2j. Plus 5j plus 3 the top line, that makes that, so that must be 15 plus 11j change minus 2. Bottom line becomes top 13 times 13 times j minus 1 2 j. That minus 22 becomes, so minus 13 plus 22 is 9, minus 26, take away another 11, is minus 37. J over 9 over 5 minus 37j over 5. But not massive. do that's a nice man in the and you're going to get more science. You're going to use these in science as well anyway, so can't get away from complex, and you use them in the